Hello everyone. In this video we are going to cover 4.2, which deals with solving compound inequalities. So in that first video in 4.1 we looked at how to solve inequalities, just a single inequality, and we looked at how to represent the solution set. So here we are going to be solving more than one inequality. So that's what we call a compound inequality. Okay, but before that, we need to do a little introduction to sets and some other set theory notation. Okay, so take notes. Use the closed captioning button down below if you need it. 4.2, solving compound inequalities. Okay, so we are going to take a look at what the intersection of two sets means and what the union of two sets means. Okay, so let's start with the intersection of two sets. So the notation for that, so if we have two sets A and B, the intersection of A and B, the notation we use is this sort of upside down U. Okay. So that means intersection. And this just means the set of all elements that are common to both of them. It's all the elements that they have in common. Okay, so let's go ahead and write that down. The set of all elements that are common to both set A and B. Okay, so for example, if I have set A is a set of these numbers, -6, 1, 2, 3, 4, and suppose set B is made up of the numbers 0, 3, 4, 5, and 6. 0, 3, 4, 5, 6. Then the intersection of A and B, again, we use this notation, would be the set of numbers that they have in common. So here we see that it would be no, 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 yes, yes. So 3 and 4. So this is a set, this is set A, this is a set, that's set B, this is another set, the intersection of A and B. Okay, so let's take a look at union of two sets. Union of two sets, and the notation we use for this is this sort of U, but it's not a U, okay. But that's one way to remember it. A union of two sets, A union B. Okay, so here the set of elements that belong to set A or set B or both. Okay, so it's the set of elements that belong to set A or set B or both. So it is essentially everything. Okay, so everything that they can muster together. Okay, so let's take a look. So in this example, suppose that set A is made up of -6, 1, 2, 3, and 4. And set B is 0, 3, 4, 5, and 6. Okay, so here, the union of these two sets, and it makes sense, right? The union of these two sets would be the set when you unite these two sets. So when we put these two sets together, then the union would be everything that they have all together. So that would be, if I go in order, -6, 0, 1, 2, 3, 4, 5, and 6. Okay, so 0, 0, 3, 4, 5, 6 is in here. 0, 3, 4, 5, 6. -6 is here. 1, 2, 3, 4 are also here. So everything all together. That's the union. And you don't have to write 4 twice. You only have to write it once. Okay? If we were to look at this using Venn diagrams, then the intersection A intersected with B would look like this. If this is set A and this is set B, the intersection would be right here, what they have in common. If we looked at A union B, then if this is A and this is B, then it's what they have all together. What A has that B doesn't have, what A and B have in common, what B has that A doesn't have. Okay, it's everything. Okay, so solving compound inequalities. And that's what we're going to be looking at here today. So it's going to be 2 inequalities, kind of like a compound sentence. So a compound inequality is 2 inequalities. So 2 inequalities joined by the word and or the word or. Okay, so just like in English class, a compound sentence is a compound sentence is 2 sentences joined by a conjunction. A conjunction is like and or but. Okay, same thing here in math. Compound inequality, 2 inequalities joined. Forgot the D. Joined by the word and or. Okay. All right, so let's take a look. Okay, so translating. Okay, so if I have this, x greater than equal to -3 and x is less than or equal to 6, then we want values. So we want x values where both of these are true. Okay, so we want x's that are greater than or equal to -3 and at the same time less than or equal to 6. So that's how we're reading this. We want x values that are greater than or equal to -3 and at the same time less than or equal to 6. So greater than or equal to -3 and also less than 6. So you can kind of imagine that it would be numbers that are in between -3, and 6. Okay, so if we graph this, right, if we graph this, here's -3. And we want all the numbers that are greater than or equal to -3. So it's going to be everything that way, right? So here I'm going to use different colors. So I'll use green. So greater than or equal to -3. So that's everything that way, right? And then we also want, I'll do in blue, the x values that are less than or equal to 6. So let me put 6 over here. Less than or equal, so we're going to be going this way, and I'll do it in blue. And less than or equal to 6 is this way. Okay. And again, so you can think of this as set A. So set A is made up of this green, all the green, and this is set B. And set B is all of this in the blue. And we want the intersection of these two. So we want where they have common solutions, right? So that would be right here in the middle. Okay, so right here is where they intersect. Right here is where they have common solutions. So I'm just going to go ahead and darken this. Okay, so we could say, okay, -3 to 6. Okay. All right. Let's take a look at this other example. So here, let me put this example. And let's take a look at another one. And let's try to understand how to translate it. So this is the and. So this is a compound inequality using and. So we want this to be true and this to be true. Okay. So which numbers have this true and this true? It's where they have the common solution. Okay. All right, so let's take a look at how to translate the or. So if I have this, x is less than or equal to -3, or x is greater than or equal to -2. So then here, we want this to be true or this to be true. Okay, so here, if I graph this, okay, here's -3, here's -2. Okay, so I'll do this one first. X is less than or equal to -3, so that we have this here, and less than equal is that way. And now I will do this one. X is greater than or equal to -2, so that's bracket, and it's everything this way. So here, or is union, so I'm taking the union of these two sets. So the union of these two sets, we could say, oh, x is less than or equal to -3, or x is greater than -2. So here, if I were to write the solution set, I would say unbounded on the left, so -infinity, all the way to -3, bounded. And then here, I would say bounded on the left, -2, unbounded on the right, so positive infinity. And what I do is I use the union symbol to represent this. Okay? All right, so let's take a look. Oh, one thing I want to also show you. Suppose this said and. Okay, remember, when it says and, you're looking for where they overlap, where they have common solutions. Okay, so if this said and, do these overlap? No, they don't. So if this had said and they want you to find the solutions for this and this, where this and this are true, You would have no common solution between these two sets, so you would have to say no solution. Okay, so remember, and you're looking for where they have common solutions, or you're just taking everything, all of this and all of that. Okay? All right, let's take a look at solving. Here. Solve and graph. All right, so let's go ahead and solve and graph. Solve and graph this. X over 2 plus 1 greater than 0. And so we'll be looking for where they overlap. 2x minus 3 is less than 5. Okay? So let's go ahead and solve each one, and then we'll graph it, and then we'll see where they overlap. Okay, so over here, I'm going to subtract 1 on both sides. And I'm going to multiply both sides by 2. So there's my first one. So greater than or equal to negative 2. Let me finish this one so I know where to place the 2, the negative 2. Okay, so here I'm going to add 3 to both sides. So I will get 2x is greater than 8. I'm going to divide both sides by 2. So x is less than 4. Okay, so I'm going to put negative 2 over here. And I want all the x's that are greater than negative 2. So I'm going to have parentheses. And I will shade all of this side of the number line. And then now let me do this one. X is less than 4. So I'm going to put 4 over here. Strict inequality, so parentheses over here, and less than. So then I am going this side. And here I can see where they have common solutions right in here. Okay, so my solution set would be negative 2, bounded on the left by negative 2, bounded on the right by 4. Okay. Let's take a look at another one. So again, and you're looking for where they have common solutions. And right in here is where we see where they overlap. Okay. If this said or, we're taking everything all together and we see that's the entire number line, except at negative 2 and 4. Okay? Because remember, parentheses means negative 2 and 4 are not included. Okay, let's take a look at this one. Example number 2, solving graph. X plus 3 less than or equal to x minus 1, and 3x minus 2 less than 5x minus 4. Okay, so let's go ahead and solve each one. Okay, so over here, again, it's and, so we're going to be graphing it and looking for where they overlap. Okay, so over here, I have x's on both sides, so I'm going to subtract x on both sides, and I'll end up with this. Okay, and then now I'm going to add 1 to both sides, and I'll end up with this. Okay, let me solve this one. Okay, so I have x's on both sides. I will subtract 3x on both sides. That will leave me with negative 2, 2x minus 4. I will add 4 to both sides. And now I will divide by 2, both sides. Okay, so these are the two inequalities that I need to graph. I need 1 and a 4. So 1 and 4. Okay, so let me begin with this one. X is greater than or equal to 4. Greater than or equal to 4. Okay. X is greater than 1. I'm going to do it a different color because I'm going to end up overlapping here. All right, so I'll do it in green. X is greater than 1. Okay, so do you see where they're overlapping? They're overlapping right here. Okay, so when you write your solution, the solution again is where they're overlapping for and. Okay, so our solution is bounded at 4, unbounded on the right. Okay, that's where they have common solution. Okay, all right, let's take a look at another one. Example number 3, solving graph. Okay, so suppose I have x minus 1 is greater than negative 3 and 2x less than negative 8. Okay, again, it's and, so we're going to be graphing it and looking for where they overlap. So here, solving for x, I'm going to add 1 to both sides. And that will give me x is greater than negative 2. Over here, I'm going to divide both sides by 2. And that will give me x is less than negative 4. Okay. All right, so let's graph each of these. Negative 2, negative 4. Okay, so let's do this one first. X is greater than negative 2. Strictly greater than. So parentheses, greater than. So that's this way. And now let's do this one. X is less than negative 4. Strictly less than. So we shade this way for less than. Okay. We're doing and. Do they overlap? They do not overlap. So there is no number x where if you plug it in here, it'll be greater than negative 3. And at the same time, this will give us less than negative 8. There is no x where this and this will be true. Okay, so because these are all the numbers that would make this true, actually this true, and these are all the x values that would make this one true. Okay, so there isn't one that makes this true and this true because they don't overlap. So here you would say no solution. Okay, if you were to use the set builder notation, right, you would do that, empty set. Okay, all right, let's take a look at another one. This here is also another way to write the compound inequality for and. Okay, so solving graph. So if you see it written like this, sort of this long string of inequalities, this here is an and. Okay, so this is an and inequality. Okay, you could break it up if you want to and rewrite it as two separate ones. You would say negative 3 less than or equal to 2x plus 5. That would be one. And then over here, you would write 2x plus 5 is less than 7. Okay, but I'm going to keep it like this. It's less writing. You still solve for x the same way, except instead of subtracting 5 on both sides, you have to do it here, here, and here. Okay, so it's like you have 3 areas. Okay, so you have to subtract 5 here, but then you have to subtract 5 here and here. Okay, so we get negative 8 less than or equal 2x less than 2. Okay, divide everything by 2, and you get negative 4 less than or equal x less than 1. Okay, And when the way you graph this, it kind of says it here already. This tells you where it's bounded on the left and where it's bounded on the right. Okay, so when you graph this, you're going to be bounded on the left by -4 and bounded on the right by 1. Bracket on this side, but parentheses on this side. And like we actually visually see this, that x is between these two numbers, and that's where we shade between these numbers. Okay, so this is another way to write the and compound inequality. Okay, let's take a look at another one. Solving graph. X over 3 greater than 2/3. Or, so now we're doing ors. And remember, or is just everything that's been shaded is your solution. Okay, so or is all of it. Okay, x minus 2 greater than 3. Okay, so let's solve each one so we can see how we need to graph them. Okay, so this one, this is divide by 3. So I'm going to multiply both sides by 3. And I get this. Okay. Here, I am going to distribute this negative. So I get negative x plus 2 greater than 3. I'm going to subtract 2. And that will give me 1. I'm going to divide by negative. Remember, when you divide by negative, you're going to have to switch this direction of the inequality. Okay, so these are my two solutions. So let's go ahead and graph these. -1 is on the left and +2 is on the right. Okay, x is greater than 2, strict inequality, so parentheses. X is less than -1, strict inequality, so parentheses again. Okay, and when you're doing or, we're not looking for overlap. Whatever we get is the entire solution. Okay, so here, so our solution is going to be, I'm going to represent this side first. So unbounded on the left, bounded on the right with 1. So unbounded on the left, bounded on the right with 1 parentheses. This one over here, bounded on the left with 2, unbounded on the right with positive infinity. And all you do is throw the u in between them. Okay. So again, with union, everything that gets shaded is the solution set. With and, it's only what they have in common. Okay, let's take a look at another one. Solving graph. X plus 3 greater than or equal to -3, or negative x greater than 0. Okay, so over here, solving this inequality first, subtract 3 on both sides, and you get -6. This one, divide both sides by negative, so we have to flip this inequality, and we still get 0. Okay, so let's graph each one. -6 is on this side, 0 is over here. So graphing this one first, greater than or equal to -6. So greater than or equal is this way. Less than 0, parentheses. Okay, so here, just be careful with this. Over here, it looks like the entire number line is included. Okay, so, but it's not. It's not everything, because 6 is included. All of these numbers are included. -6 is included. All of these numbers are included. All of these numbers are included. But right here at 0, 0 is not included in our solution set, right? We have a parentheses here. So we can say all real numbers except 0. Another way to write that is all real numbers except 0. That's one way. Okay, if you use the interval notation, then it's everything up to 0. So unbounded on the left, bounded at 0. So unbounded on the left, bounded at 0. And bounded on the left from 0 to infinity. This is also another way to write it where you exclude you exclude the 0. You include everything except 0, because it's saying everything, stop at 0, don't include it, and then starting from 0, everything. That's what this is doing. Okay, and again, you have to use the parentheses at that point of inclusion, 0. Okay, 6 is included. It has the bracket. Okay. All right. We made it through. Okay, so if you have any questions, just message me. Keep up with the homework. I'll see you next time.